didn't have my calculator, for these problems, I would be using my special angle button, or my special sign button, I mean. I would be finding the angle whose sine is negative root 3 over 2. This is what we just talked about, so you should remember this. This is very recent. Oh wait, I never finished this one. Let me finish this one. Secant 5 pi over 3. That's 300 degrees. Pi 180 divided by 3 is 60 times 5 is 300. So I know my labels for my regular math, my regular trigonometry. Here's 300. So this is 360. So this angle right here is 60. I've got to get from 300 to 360. Right there it is. I know that my sides are that. Notice I just dropped my negative in automatically because I recognized it was going down, and going down is negative. Positive, negative. Now I want the secant. Okay, I got to remember what the secant is. The secant is reciprocal of cosine. Cosine, so cosine is adjacent over hypotenuse. So I want the reciprocal of that, which is hypotenuse over adjacent. So hypotenuse over adjacent would be 2 over 1, which is 2. So the answer to 5D was 2. Now I'm going to do 5E. This one says, find the angle whose sine is negative root 3 over 2. So I am finding an angle. First thing I need to do is draw it. Now where do I draw it? There are rules. Do you remember what the rules are? What are the rules for this notation? Inverse sine. Right side, over there. And then what did we talk about? We're going to draw a triangle up here, or we're going to draw one down here. Look at that number. It's negative. I am not going to draw it in quadrant 1, right? Because why? Because nothing's negative in quadrant 1. So I've got to draw it in quadrant 4. These are my only choices. 1 and 4 are my only choices when I see that word, that notation. So the sine is opposite over hypotenuse. The negative makes sense. What is the adjacent side? 1. How big is that angle? How big? 60. But don't say the answer is 60, because 60 would go this way, right? So it's not positive 60, it's negative 60. So the answer to the question is negative 60 degrees. Same problem, only now we want the angle whose cosine is negative 1 over root 2. That's right. Caesar's back there going like this. When you see that notation, you know you're up here. You're in the top half of the circle. Those are the rules. Didn't make them up myself. That's the way it is. Now, again, I'm either going to draw a triangle over here or over here. So I look at this number. It's negative. That's going to have to be over here. Because again, if it's negative, it can't be in quadrant 1. If it's positive, it will be in quadrant 1. But if it's negative, it won't. So here we go. Cosine, adjacent over hypotenuse. Again, doesn't that negative make sense? What's the third side of the triangle? 1. What's the reference angle here? 45. Now, if you tell me the answer is 45, you're going to be wrong, because this is 45, and that isn't what I want. If you tell me the answer is negative 45, you're going to be wrong, because this is negative 45. What is the answer to this problem? 135. 135 degrees. is the answer to the problem. Next set. Number 6, this is a thinking question. You have a 25% chance of guessing correctly, because there are only 4 quadrants, but let's try to narrow it down and figure it out. It says the sign is positive. The sign is positive. So if we think about that for a second, think about your triangles. Sine would be opposite over hypotenuse, right? Now, where could it be? Anywhere in that picture, where could it be that the sign is positive? That's what greater than 0 means. So where will opposite over hypotenuse be a positive number? Positive here? What about opposite here? Wouldn't opposite be negative? Opposite would be negative over here, wouldn't it? Wouldn't it be here and here? You guys think you want this side and this side, okay? This one's always positive, so you don't even really have to worry about it. Isn't for this angle, isn't the opposite side positive? What about for this angle? Positive? Now see why it doesn't work for this one? Wouldn't that opposite side be negative? And wouldn't that opposite side be negative? So this is only going to happen here and here, quadrant 1 and 2. Now I want the cotangent to be negative. Now look at these 2 quadrants right here. What's cotangent? Well, adjacent over opposite. So if you put adjacent over opposite in quadrant 1, would it be negative? No. So that one doesn't work. What if you did it over here? If you put opposite over adjacent, would that be a negative number? So your answer is quadrant 2. In quadrant 2, you have, and if it helps you, you could say, okay, positive, positive, negative, positive, negative, negative. You could set up your triangles like that, because you know right and up is positive, left and down are negative. All right, number 7, we had a quiz over this, and it was pretty easy for most of you. So let's see if we can talk our way through these graphs. Now, one thing, I see over to the side, I've asked you for the period and the amplitude. So let's get a graph first, and we'll talk about what those 2 numbers mean if we haven't already. All right, so tell me about that. You're going to graph this thing. Do you remember what a cosine even looks like? Cosine starts at the top, ends at the top. So here is my cosine curve. There it is. How about these labels right here? What are these guys going to be? 2/3 and negative 2/3? That is called the amplitude, or the height of the curve. So this curve is 2/3 tall. If there were a 6 out here, then you would make these 6s, right? And then the amplitude would be 6. The amplitude is just how tall it is. Those are sound waves. What happens when you turn up your amplifier? It's higher. The waves get higher, increases the amplitude. All right, now how about these labels? What's this last label supposed to be for a cosine? 360. It's supposed to be 360, right? But I put a coefficient on here, and what does that coefficient do? Well, it divides by a fourth, which is the same as timesing by 4. So that end point now is 4 times further than it was, 1440. That, my friends, is the period. The period is how long it is. The amplitude's how tall it is. The period's how long it is. Okay, those are just math words we use for height and length. So, what's this one right in the middle? Well, they're supposed to be 90, 180, 270, and 360, right? But when you multiply that one by 4, you're multiplying it all by 4. So this one's going to be, yeah, this one will be 720, this one will be 360, and this one will be 1080. It's all the normal labels times 4. And we times by 4 because of the 1/4. Two tan x. All right, tell me about this one. What's this one look like? What does a tangent look like? It has an asymptote and an asymptote and a squiggly line in the middle, right? Where are the asymptotes supposed to be? Negative 90 and positive 90. That's where they're supposed to be. Guess what? We didn't change them. How come we didn't change them? Because there's no number here, right? This is the number that divides your length. Now what's that 2 do? Nothing. Because that number out in front is the height, right? What about the height of tangent curves? They don't have height. So when we talk about amplitude for this one, we have to say none. There is no height. There is no amplitude for a tangent. Now the period is a little tricky. Period is the length of the curve. Now over here, I said it was 1440 because we started at 0 and ended at 1440. Be careful. What's the period here? What's the length? 180. Why is it 180? Because you've got 90 over here and 90 over here. So the period is 180. Here, you went from 0. So all you had was that 1440. So that was your length. Here, you're going 90 this way and 90 this way. So it's a total length of 180. All right, now we have a sine curve. All right, so here we go. Everybody remembers where, oh wait, this is negative. This is a negative sine curve. So what does that change if it's a negative sine curve? Flips it upside down. So a normal one would have the hill and then the valley, but this guy's going to have the valley first. That 3 tells me that I'm going up 3 and down 3, which means your amplitude is 3. It's the height. Isn't that 3 tall? Now what about the period? Well, these normal labels, that's 360, 270, 180, and 90. Those are the normal labels. But what have we done here? What has happened? We have have divided by 2/3? So we have 360 divided by 2/3, which is 360 times 3/2. What's 360 times 3/2? 540. What's 90 times 3/2? Because remember, if you're multiplying this by 3/2, you're multiplying all of them by 3/2. So what would this be? Oh, it's not 360.
135.
135. This one's 270, I think. This one's 405, maybe, and 540. So how did we get those numbers again? We took the regular labels and times them by 3/2. What's my period? And my amplitude is 3. What's my period for this one? 540. Period is length. How long is it? Side to side. All right, we're going to get through the calculator exercises and then we'll be done. So, everybody who has a calculator should have it out right now. Let's set it in degree mode. If you probably are already, but just in case, set it in degree mode. Now, we haven't done this in a very long time. Problem 8. Problem 8 says, change 18.775. So I typed it in, 18.775. Now I want to change it to degrees, minutes, seconds. Remember how to do that? I go into second apps, that's my angle menu, and I click all the way down till I get to DMS. Because what does DMS stand for? Degrees, minutes, seconds. So I click down to DMS, press enter 2 times, and you should have gotten 18 degrees, 46 minutes, and 30 seconds. So let me do that one more time. I type in the number they give me, 18.775. I go to second apps. Phil, would you work with us, please? You need your calculator, which you have. God bless you. Turn it on. Type 18.775. Now go to second apps. Click down to DMS. Press enter a couple times, and you get 18:46:30. Right, everyone? So now we can do that. All right, now we're going to do kind of the opposite. We're doing problem A. It says find the sine of 2814. So I'm going to press sine 28. Now I need my degree symbol. All right, so I go back to second apps, and there it is. And then I need 14. Go back to second apps, click down to the minute. I got 0.4731. Did you? 0.4731. It directions say 10,000, which is 4 decimal places. So for problem A, 0.4731. Now I'm going to skip B for a minute because B is in radians. And I don't want to change my calculator. So I'm going to do all the degrees. So I can do C. Here we go with C. Second cosine, 0.376. What did you get? 67.9139. 4 decimal places. 67.9139. D. Uh-oh. How do I type that on my calculator? Secant 19. How do I do a secant on my calculator? I heard somebody say it, I think. 1 over cosine. So you're going to divide, or you're going to write, or type in simply 1 divided by cosine 19. 1 divided by cosine 19, 1.0576. 1.0576. Is that all right with everybody? How do we type a secant in on our calculator? 1 divided by cosine. Perfect. Perfect. Cosine 98, anybody that can't do this is in bad shape. Cosine 98 is negative 0.1392. Negative 0.1392. F is a cosecant. How do I type a cosecant in on my calculator? 1 divided by sine. Now I got to put all that stuff in. 15 second apps degrees. 19 second apps. Go down and get minutes. Oh, how do I do that seconds thing? I type in my 11, and then where do I get the seconds? Alpha plus. 3.7849. 3.7849. Would somebody give me an agree? Whoa, 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 we got 1 to go. Which one's left? Yeah, we didn't do B. Change your calculator into radians. That's a radian measure. Mrs. Ford, how do I know that's a radian measure? It does not have a degree mark. That's how I know it's a radian. So I changed my calculator into radians and type tangent, 1.15. The answer is 2.2345. 2.2345. How cool is that? But that's finding an angle. So that one, Melissa, actually, you could do either in degrees or radians. Either one would be acceptable. You'll get different looking answers, but either one would be fine. Yep, Meredith, I hope you get feeling better.